In 2017, our planet briefly crossed paths with one of the strangest visitors in astronomical history, an object from deep interstellar space that challenged everything we thought we knew about how space rocks move and behave. Years later, in 2025, another mysterious traveler is diving toward our sun, and this time we are watching the story unfold in real time. Segment 1. The First Interstellar Messenger. Astronomers named the first object One-Eye Oumuamua, a Hawaiian word meaning scout or first distant messenger, because it was the first confirmed interstellar object ever detected in our solar system. It likely spent millions of years drifting between the stars before its path happened to intersect the tiny slice of space we call home. By the time telescopes identified Oumuamua, it had already swung past the sun and was racing back out into interstellar space, giving scientists only a short window to study this cosmic visitor. Segment 2. Too fast to belong here. Everything that's born in our solar system is, in some way, bound to the sun's gravity, moving in closed, looping orbits. To break free, an object needs to reach what physicists call escape velocity, which near Earth's orbit is on the order of a few dozen kilometers per second. Oumuamua, however, was traveling on a hyperbolic trajectory, moving fast enough that it was never going to be captured by the sun and will never come back. Its orbit had an eccentricity greater than 1, a clear signature that this object came from outside our solar system. Segment 3. A shape and brightness that make no sense. When we look at small objects in space, we mostly see points of light, tiny reflections of sunlight against the darkness. Most asteroids are dim and roughly spherical, so their brightness stays relatively steady as they spin. Oumuamua behaved completely differently. Its brightness changed dramatically over time, suggesting a very elongated or flattened shape tumbling through space. It also appeared unusually reflective, hinting that its surface composition might be very different from the dark, rocky asteroids we're used to seeing. Segment 4. The Mystery of the Extra Push. As Oumuamua moved away from the sun, astronomers noticed something even stranger. It seemed to accelerate slightly, as if an invisible force were giving it an extra push. Comets can do this when sunlight heats their icy surfaces and gas jets act like tiny thrusters altering their motion. But Oumuamua did not show the usual signs of a comet: no visible tail, no glowing coma of gas and dust around it. To explain this behavior, some researchers proposed the object might be made of exotic ices such as nitrogen or hydrogen that could sublimate without producing an obvious tail, while others wondered, half seriously, if this could be a piece of alien technology. Segment 5. Not alone. 2I/Borisov and 3I/Atlas. For more than a century of sky surveys, astronomers had never seen an interstellar visitor. Then, within just a few years, we discovered not one, but 3. In 2019, a second object, 2I/Borisov, was found by an amateur astronomer and soon confirmed as an interstellar comet. Unlike Oumuamua, Borisov looked and behaved much more like a normal comet, with a clear coma, a tail, and ices similar to those found in comets from our own solar system, giving scientists a rare chance to compare building blocks from another planetary system to our own. In 2025, astronomers announced 3I/Atlas, the third known interstellar object, and another comet racing through the inner solar system. Detected by the Atlas survey, this visitor follows a fast, unbound path past the sun and across the orbits of multiple planets, again confirming that small fragments from distant star systems regularly wander through our cosmic neighborhood. Segment 6. Clues to Ancient Worlds. Each of these interstellar objects is a frozen time capsule, carrying physical clues about the worlds and stars that formed them. Some models suggest that Oumuamua could be a shard chipped off a Pluto-like world rich in nitrogen ice, while 2I/Borisov and 3I/Atlas seem to resemble more traditional comets, hinting at familiar chemistry in distant planetary systems. By tracking their paths through the Milky Way and measuring their composition, astronomers can piece together how often planetary systems eject debris into interstellar space and how similar or different those systems might be from our own. Segment 7. Nature or Technology. Whenever nature presents us with something truly strange, our imaginations jump to the most dramatic explanation. In the case of Oumuamua, the combination of its odd shape, unusual reflectivity, and unexplained acceleration has led some scientists and many enthusiasts to consider the possibility that it could be a defunct probe or light sail from an advanced civilization. Most researchers favor natural explanations involving unusual types of ice, gas release, or long-term erosion in interstellar space. But the debate itself has pushed astronomy to test its ideas more rigorously and to design better ways to study the next visitor that comes our way. Segment 8. A new era of interstellar archaeology. With modern survey telescopes scanning the sky every night, the odds are rising that we will discover many more interstellar objects in the coming years. Future missions may even be able to launch spacecraft to intercept one of these travelers, capturing close-up images and samples from material that was born around another star. Each new object that passes through our solar system turns empty space into a laboratory, letting us observe the physics and chemistry of distant worlds without ever leaving home. Closing line. We are only at the beginning of this journey into interstellar archaeology, and every strange visitor that brushes past our sun brings us one step closer to understanding how life-friendly planets like Earth emerge in a vast and ancient galaxy. So if you want to follow the story of the next cosmic messenger that dares to cross our path, make sure to subscribe and stay tuned for more journeys into the deep universe.